What we're going to be talking about today are rational expressions. And what I know from earlier chapters and sections is that the word rational means what? It means fractions. I'm going to try to pause when I'm making these instead of rolling through it, but I probably won't do a very good job. Rational means ratio. Ratio means fraction. So we're going to be looking at expressions that involve algebraic expressions. So things that look like x plus 5 over x minus 2 would be an example of a rational expression. Something like x squared plus 3x plus 2 over x squared minus 4 would be an example of a rational expression. Maybe 3x squared minus 6x over x squared minus 5x plus 6 would be an example of a rational expression. Maybe I can fit them all on one page. Okay. Now, when we start off working with rational expressions, we need to talk for a moment about the domain. Okay. When we are talking about the domain of an expression, and we've used the word domain before with functions, remember the domain was a set of x values. Whenever I have a fraction and there are x's involved in that fraction, I have to make sure that I never choose a number for x that makes me divide by 0 in any step. Okay. Because a number divided by 0, 5 over 0, negative 2 over 0, that's undefined. I don't know how to explain that or describe that or define that to a reader or to a user. So as soon as there are x values on the bottom of a fraction, I have to be concerned about any restrictions that there might be on the domain. Okay, sorry about that. So again, a 0 on top of the fraction is not a big deal. 0 divided by 12 is 0, and 0 divided by negative 0.7 is 0, and 0 divided by anything is 0, so that's not our concern. When I'm worried about, when I'm looking for restrictions on the domain, okay, I'm going to start by taking the bottom, whatever it happens to look like, okay, whether it's x minus 2, or x squared minus 4, or x squared minus 5x plus 6. I'm going to say I am in charge of figuring out when that is equal to 0. Okay, I have to figure out what numbers would cause a problem. And so if I solve x minus 2 equals 0 for x, I find out x equals 2. If I want to solve x squared minus 4 equals 0 for x, so we just wrapped up with the end of the last chapter. If I have x squared in the problem, I have a 0 on the other side. I'm going to factor it if it factors. X squared minus 4 is a difference of two squares that I have to know how to factor. A squared minus b squared, how does that break down? And once I'm here, I set each factor equal to 0, and then I solve for x. Still don't like that, sorry. So my two solutions here are positive 2 and negative 2 if I add 2 to both sides or subtract 2 from both sides. Okay. Go ahead and pause the video for a moment if you'd like. Factor the bottom expression x squared minus 5x plus 6. Set each factor to 0 and solve for x. Once you've done that, turn the video back on. Alright, if you were careful with your signs when you factored this, you should have come up with x minus 3 and x minus 2. I'm not showing my steps because I'm in a hurry. Okay. For your solutions. Okay. Now, what we've done is not found the domain. Okay, I used the word domain, and I've written that in blue off to the side. But we said I need to be able to tell the reader when they look at this problem what numbers they cannot use. Okay, the domain is the numbers, the set of numbers that we can use. And there's so many of them that it's hard to list them all. Okay, but if I make a list that's short and sweet in each of these examples and say you can use any number that you want to except for this set right here, okay, that's what we're going to do. So when we give the domain for any of these expressions, okay, your author will write this in a number of different ways. I don't care about the formality. If you like his set builder notation, feel free to use that. If you want to use words, you can tell me that way. But once I have set the bottom to 0, I've solved for x, and I've solved then to find out that 2 is the number I can't use. When I come over to the domain, I need to put a line through my equal sign. Okay. If you are still doing Chapter 5 homework, do not go back and draw a line through any of the equal signs from that last section. Okay. But not equal to part of this here, as we're saying these are the numbers that we cannot use because it makes me divide by 0 in this particular problem. So there's two numbers, and you can write them separately if you'd like. You can say x cannot equal 3, x cannot equal 2. But in words, it should be understood to the reader that when they see this, that means I can use any real number that I want to except for the number 2. And you can say it in words if you'd rather say it that way. The domain is all real numbers but 2 in the top one, or all real numbers but 2 and negative 2 in the middle, or all real numbers but 3 and positive 2 in the bottom. Okay. But if I'm asked to find the domain, and this is just one of many situations where it's easier to eliminate values from our list instead of making a list of all the things that we can use. Because the number 2 is the only number we cannot use in the top problem. Okay. Anything else is fair game.